Okay, so this is our last part of logs, and it's using logs to draw graphs. So this is a really quite a long question within a paper, but all of them take exactly the same format. So once you're kind of comfortable with the format of the question, you will see all of them are exactly the same. Okay, so basically this is how do we get a relationship into the form of a straight line graph. Okay, because straight line graphs are really useful. We can find gradients from them, we can find intercepts, we can put in a point and find another point on the line. So they're a really useful tool to have. So this is about getting some kind of data and taking logs to make it into a straight line graph. It'll all become clear in a wee second. So we're going to look at two examples. Here's our first one. A formula for n is n equals a times v to the power of b. Values of n and v are given below, and we can have this table with our values for v and n. And part A then asks us to find a and b. Now, if we plotted all those points and on a graph for v and n, we wouldn't get a straight line because this isn't the format for a straight line graph. Okay, so it wouldn't help us any. So if we, though, take this equation and take logs at both sides, the way you did whenever you were solving equations, and then I'm going to separate out our right-hand side here, and we get log a plus log v to the power of b. Now I'm going to take the b down. I'm just going to put it first, b log v plus log a. So if we think about the equation of a straight line, y equals mx plus c, where m is the gradient and c is the intercept, we're going to use log n to be our y values, log v to be our x values, and then we can find b because it'll be the gradient, and we can find log of a because it's the intercept, and then that'll help us to find a. So we need to find the values, instead of the values for v and n, if we find the values for log v and log n, then we can draw a graph, and it has this format, y equals mx plus c, so it's a straight line. So the first thing we're going to do is redraw this table and get values for log v and log n, and be very clear which ones are our x values and which ones are our y values. So if we look, our values then for v and n were given to us, and we're going to find the values for log v and log n. So remember from our previous slide there, log v, these are our x values, so you plot them on the x-axis, and our values for log n are our y values, so plot them on the y-axis. So to find these, you just type them into your calculator. So you type log 3.5, write them to at least 3 decimal places, unless the question tells you otherwise. So we're just entering each of these in to our calculator to get log of 3.5, log of 6.4, log of 8.2, and so on. Then to get our log n values, put in log of 13.38. And again, the same thing with all our values. Okay, so now whenever we go to draw the graph, your x-axis will be log v and your y-axis will be log n, and that's where we'll plot the points. Now, quite often in an exam, the axes will be drawn for you and you'll just work from that, because it can be awkward enough to draw these on. Try and draw, put a nice big scale on it. So for this here, we have to go from 0.5 up to 1.1. So don't worry about starting from 0. Start from 0.5 and go up to 1.1. Okay, and the same thing with the y-axis. It goes from 1.1 up to 1.8. So start at 1.1 and go up to 1.8. So as you can see, I've cheated a bit and put an image of the graph in from your textbook. So you can see the points plotted there will go from 0.544 on log v and 1.126 up on the log n axis. So you plot your points and they should form a straight line. Okay, and then from that we can find the gradient and we can find the intercept to be able to get the values for A and for B. Okay, so finding B first of all. So B is the gradient of that line. So pick 2 points on the line. Now I'm going to pick the first point that you plot, 0.544, 1.126, and the second and the last point then was 1.072, 1.791. Okay, so that's your first point that you plotted and the last point. So to get the gradient, remember you do y2 minus y1 over x2 minus x1. So we'll get 1.791 minus 1.126 over 1.072 minus 0.544, and you get that B is 1.26 to 2 decimal places. So then to find A, pick points. So from your table, when V was 3.5, N was 13.38, and B was just found out as 1.26. So put that into our formula, N equals A, V, B, and we should be able to work out A. So we'll get 13.38 equals A times V, which is 3.5 to the power of 1.26. So you do that on your calculator, and we get that is 4.848. So we're going to take that across and divide by 4.848 to give us A. So A works out to be 2.76 again to 2 decimal places. And the next part of the question will be to use that equation. So find N when V equals 5.4. So our equation is N equals A V to the power B, but we know A and B now. So N equals 2.76 times V to the power of 1.26. So put our value of V in. It's 5.4 to the power of 1.26. Do that on your calculator and we'll get 23.11. And then part 2, find V when N equals 75. So again, put that into your equation. So we get 75 equals 2.76 times V to the power of 1.26. So the first thing I'm going to do is to have 75 divided by 2.76. So we'll get V to the power of 1.26 equals 27.174. Now this is, you have to go back to the previous exercise when you're solving equations like this. We'll have to take logs at either side. Bring the 1.26 down. And then divide through by 1.26 and we'll get, so the log of 27.174 divided by 1.26 gives you 1.1382. And then if you use the inverse log button, so shift and log, you can find V, and it's 13.75. Okay, so that's one full question. Now sometimes they'll ask things like why might there be an issue with this part 2 of B? And the reason is because n is 75, and if we go back and look at our table, our values of n are between 13.38 and 61.87. So 75 lies outside the range of the original values. So we hope that the relationship is the same outside these values, but it might not. Whereas in part 1, our values for V go from 3.5 to 11.4. So 5.4 is in that region, so it should be fine. It's just that our 75 is outside that region. Example 2 then, this is a typical exam question where they put in some kind of scenario around the values. So Willow measures the curved surface areas, A centimeters squared, and height, H centimeters, of different solids. These values, the values of 5 of them are below. So it gives you a table of values of heights and areas of 5 different shapes. Willow believes that a relationship of the form A equals BH to the power of n exists where B and n are constants. So the questions will always look like that. You'll get a table of values. You will see this type of equation, and then you know it's a log graph question. Okay, so that's all the preamble, and then we'll get on to part A of the question. Part A then, verify this relationship by drawing a suitable straight line graph. So the relationship that Willow thinks exists is A equals BH to the power of n. So we take logs at both sides, and hopefully you can see the similarity now of this question to the last question. We use our rules of logs to separate the right hand side out. Then I'm going to bring the n down, and I'm going to write it first. So n log h plus log b. So if we compare that to y equals mx plus c, we have log a are going to be our y values, log h will be our x values, our gradient then will be n, and our intercept is c. So then what we have to do are redo our table of values. So we have the values for h and a. So h was 6.4, 9.5, 12.2, 16.4, 22.5. So we need log h then. So again, we just put it into our calculator. Log 6.4 equals 0.806. Then log of 9.5, 0.978, and so on. And again, keep it to, say, 3 decimal places, unless the question tells you otherwise. Then our values for A that we were given in the question were 45.81, 75.05, 102.6, 148.51, 220.52. So we need to find the values then of log A. So the log of 45.81, 1.661. And again, we carry on the whole way down the log of these values. Three different places then. Okay, so just be really careful, and I would always put on the table of results which are x values and which are y values. So our log h are x values, so that's going to be the x-axis, and our log a are the y values. Okay. So again, I've cheated slightly and taken the picture of the graph from the book, but these are all your points that you've just found. So 0.806 was your log h and 1.661 was your log a, and we've plotted those points, and you can see they make a straight line. So you need to say then there's a straight line drawn Okay, so the points all form a straight line. If you're trying to verify this relationship, they have to be in a straight line. If they were all over the place, so if you had one point here and then another point up here and another point here and another point up here, that wouldn't verify the relationship. But because they're all in a straight line, we can say that the relationship of A equals BH to the power of n is verified. Okay, so then part B, find the values of n and b. So n, first of all, remember it was the gradient. So pick 2 points again. I'm picking the first point, which is 0.806, 1.661. That's the first point in the graph. And the last point in the graph is 1.352, 2.343. So then put that into our formula for the gradient, y2 minus y1 over x2 minus x1. So 2.343 minus 1.661 over 1.352 minus 0.806. Put that into your calculator and we'll get 1.25, and that's the 2 decimal places. And then to get b, you can go back to your original table, and whenever h was 6.4, a was 45.81, and we have found that n is 1.25. So put that into our formula, a equals b h to the power of n. So we get 45.81 equals b times 6.4 to the power of 1.25. So on your calculator, do 6.4 to the power of 1.25, and we get 10.179. Bring that across and divide by it, and that gives us b, and b turns out to be 4.5. Part C then, find the curved surface area of a solid of height 14 centimeters. So remember, our equation was a equals b h to the power of n. So we worked out that that was a equals 4.5 times h to the power of 1.25. And you just have to remember that the a is the area and h is the height. So when h is 14, a is going to be 4.5 times 14 to the power of 1.25. Put that into your calculator and we get 121.86. And remember, it's area, so our units are centimeters squared. And the last part of the question then, find the height of the solid with a curved surface area of 239 centimeters squared. So remember, our formula was a equals 4.5 times h to the power of 1.25. So when a is 239, put that in. I'm going to take the 4.5 across first of all and divide by it. So we'll get h to the power 1.25 equals 53.11. Have to take logs at both sides. Take the 1.25 down. So log of h equals log of 53.11 divided by 1.25, which is 1.18. So that's the log of h. So to get h, the inverse log, and we get 24 centimeters.